Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to the coding and examples section of chapter 7. This is a lecture on that particular part where we'll be discussing some examples and in particular some of the particular uh, problems that we face when we are using strings and the enum operator. So the two new things that we've learned in this particular chapter. So I think I'll be talking more about enum quite a lot in this particular section, the examples for enum, and then we'll also see a lot of different functions that are related to string data type, and we'll see how they're used and what are the important and particular usages in real life where we can actually apply strings. You'll also note that when I use enums, there will be one way of doing your projects. So for your project, it would be a very nice way to, or a very nice example of real life game, which we'll be seeing in this particular lecture. And you'll see how useful enums are in collaboration with, for example, ifs and else's and loops and other function calling, etc. So we'll see all that in this particular lecture, and you'll note the importance of strings here and string functions and enums in this particular lecture. So, if you remember the lecture on chapter 7, which was user-defined simple data types, namespaces, and the string type, you'll know that the first few objectives were where we were learning how to create and manipulate our own simple data types, which we call the enum types. We explored how the assignment statement and arithmetic and relational operators work with enum types, and many other things like using loops, using input data, and other stuff with enums. So I'll start directly this time with an example of enums, and then we'll talk about different functions of strings in this particular lecture. So this is the rock, paper, and scissors code. This is a traditional game. And this program actually plays the game of rock, paper, and scissors for you. I have not played that game, so I have no idea how this game is played. Neither have I looked at the rules of this game yet. So I'll try to just go through the code and see what the code does. And mainly my main focus would be on how the enum data type has been used here. So it's not the game that is important for me here. It's the enum data type. And I wanted to start with this lecture because you also might be given some game in your project. So I'd really like to kind of head this. I really wanted to upload enum and the lecture on enum before I actually gave you the projects. So this is the last lecture after which I'll be uploading the projects for you and sending them to you. Probably within like 10 odd hours or something. So let us now begin with the example here on that you can see on the screen. And this is about enums. And well, first of all, the first thing that you need to notice here is how the enum object type has been created here with basically three options. So the object type can either store the value rock or paper or scissors, right? So that is the take home message here. So this is how you declare an enum, and this is how you assign it different options. At the same time, note that this is not an anonymous type. So the anonymous type, I would not have mentioned any name here. And instead just maybe, enum, rock, paper, scissors. And then there are certain repercussions of that particular type of declaration. But in this case, we are declaring it properly. We're declaring it as an enum. And of course, we are using the namespace std. You have also studied the importance of namespaces in this particular lecture. So let us start with this. And here another example that we see in the function prototypes is that it is used as a return type in certain functions. So we can return if it's rock, paper, or scissor by a certain player. So whatever the selection is, based on that, we can retrieve the play here. And then the next thing is that it is also used as a probably as a function parameter as well. So it's not only used as a return type, but it's used as a parameter, and at other places it uses both return type and parameters, right? As well as, for multiple parameters as well. And we noticed that it is usually passed, or in all these cases it is passed as by basically by value and not by reference. Instead, only the, for example, this one, the winner, etc. And this is the only one place which is passed by reference. So the winner will always be an int, and that int can be replaced. So that's the main thing here. Anyway, if you notice all of these, so this is what you call the function declarations, the function prototypes, and basically object types. Then you've got a main function here which goes on, which declares some parameters and variables, and then it basically you can notice that it's using the object type, which is basically this one, and named it play1. So it will then use play1 and play2, etc. for deciding different players, and they can have their own selections. Player one can have selection in play one, and player two can have the selection in play two. Then you've got some other variables that are initialized, and you use a function display rules function. And what does display rules do? Well, display rules basically displays all the rules. Welcome to the game of the rock, paper, and scissors. This is a game for 2 players. For each game, each player selects one of the objects, rock, paper, or scissors. The rules for winning the game are this: if both players select the same object, it is a tie. Rock breaks scissors, so player who selects rock wins. Player covers paper covers rock, so player who selects paper wins. Scissors cuts paper, so player who selects uh, scissors wins. So enter R or R to select rock, P or P to select paper, and S or S to select scissors. We know that for each of these, I mean, if it's R, R, P, P, or SS, we know that these are all valid selections. Otherwise, you'll not return false. And if the player selected R, then the object is rock. If the player selected P, then it is object is paper. Notice that there's no break statement here. So this is the funny thing. This is a switch case statement that you've already seen, and we'll be using them as you can see on the screen. So this is an excellent example of how not having a break is being used for our own purposes. So it's basically case is capital R or small r will print the same thing. But this is how you do an or statement in a for a condition in a switch statement. Also note another thing, the indentation here. So switch, the case is indented right with switch, right? So this is a good programming practice. This basically shows that these cases are for this switch. However, if it was something inside the cases, you can always see them with the tab here. So the tabs are also shown here, and this is a really good programming practice that we see for switch statement. This is the traditional programming practice. Of course, if you put a tab over here, I won't mind that, it's still fine, but this is not something that is traditionally done exactly in that manner. So that's why I'm not using it. I'm showing you the traditional way and not using the tab structure that I recommended earlier. And in this case, we see that, there are these different things. We're returning the object. So the object is basically an object type of object. And we see that the return type of this function is also object type. And we see that, you just return the object, this returns the object type. And this can then be used in the main function or from wherever it is being called. Similarly, you've got the winning object. If player one is rock and player two is scissors, or player two is rock and player one is scissors, then return rock. So whichever player actually chose rock, he should be returned, right? Otherwise, if player is this and this and this and this and return paper, otherwise we should return scissors. So we decide the winner based on this. And finally, you have got these. If player one is equal to player two, then there's no winner, right? So both players are selected the same thing, and this is what they selected, right? This game is a tie, and then we kind of move on to the next step. Otherwise, there's a winning player, and that winning player is player one selected this, player two selected this. And notice the function we are using, the convert enum player two or convert enum player one. So what does a convert enum function do? A convert enum function basically displays, this is just a display of the object itself, and we know that enums cannot be displayed directly, but instead what we can do is we can display them using the cout, and this is what is exactly being done over here. And there is a slight issue here that I must correct right away, actually. So if I were to code this, I would have done it like this, followed by an enter here and a tab here, right? So This is how I would have coded it. But anyway, since I'm using the default code, I'm not going to going to rerun it again. Anyway, so what you see here is these are all these different functions with the particular things that they're doing, and they're using the good programming practices. So they all have the tabs. This is how I want you to make your projects. I'll be specifically looking for tabs. I'll be specifically looking for proper indentation. I'll be specifically looking for proper commenting. So for example, in this particular example, what I notice is that I really want some kind of comments before each function as well, introducing what this function does. So what does the game result do? What does the function winning object do? And so on. For each function, I would like to have some kind of commenting or documentation. Similarly, in the main function, although this much is good, I can kind of understand that it's step 6e, so on and so forth. So in step 6, we are basically, this is what we're trying to do. And then you've got different sub steps within the while and so on. But I would have liked some more, for example, instead of putting 6a and 6b and so on, I might have gone for basically ask the user player 1 to select, make a selection, ask player 2 to make a selection, ask, and so on. Have some proper English comments, not, mechanical comments like those that are given here. Similarly, if I go up and just think of this as maybe one of your projects that you might be submitting, or of course your projects will be a slightly more complicated than these ones. And in those cases, I would really like to see the proper indentation, proper commenting. So at the top, I can see some program comments. At the bottom, as I go, I would like, maybe with each function prototype, I would like some kind of declaration of what this function does. And yeah, something like that. So that is the first example of enums for you. And this is how enums work. And this is the example that I took to start off with enums. Now we will move on to the second case, which is basically the different functions for strings. And I'll give you a lot of different examples here. So for example, let's start with the clear arrays empty length function. So what it does is that it talks about the three main functions, how the clear operates, how the empty operates, and how the arrays operates, etc., etc., and also how the length operates. So this is what you need to notice about it. So for example, let's say that you declare some strings. First name is basically Elizabeth. String name is first name plus Jones, so it's Elizabeth Jones that is stored in the name. Then you have got string 1, which is it is Sunny. String 2 is empty. String 3 is computer science. String 4 is C++ programming, and string 5 is Elizabeth is taking C++ programming, right? So then we declare from string header, we actually take the size type, right? So this is a particular thing where we define length as the size of the length as the size of length for the size type, right? So here is what we do. The next thing is string 3, we display string 3. So string 3 is currently computer science, right? So in this case, string 3, we are supposed to get an output which is computer science. Then we clear the string, use the clear operator. What does the clear do? After clear, the operator is, again, we print string 3, and notice what's the difference between the original string 3, which is basically computer science, versus after it is cleared. The cleared function, as you know from the lecture, would basically clear everything in the string and make it a null string, right? So it will remove everything from the string. Then you've got empty function. And what does the empty function do? Well, it empties the string. And we already know what string 1 is. So string 1 is basically it is Sunny, and then we empty it, and then the result after emptying is played for string 1 and for string 2 as well. String 2 is already empty. We'll notice what happens over here. Then you've got string 4, where you use the arrays function, and basically in arrays function, if you notice, it is basically the size t, position, size t underscore n. So from position, how many number of characters do you want to erase? So from position 11, we don't want to remove the last 4 characters. And this is what happens after arrays 11, 4. This is the result. Similarly, you calculate the length of different strings, and then you convert them to int and display them. So length should all be displayed as integers. And finally, you have got name.length. Length is equal to name.length. So length you already declared as a string size type. So size type length is declared, and then we declare that what is the length of name, right? So name is the original string again. So I'll just run the code here for you to see, and what you notice is these results. So string 3 computer science. So string 3 originally is computer science, right? So for this, the result that I'm getting is computer science. When you clear it, when you perform the clear function, we notice that string 3 is basically empty, right? So there's nothing left in string 3. So that's the first thing. This line after, so the clear function actually empties up or removes everything that is inside string 3. Okay. And in the second case, when you use string 1.empty, so string 1.empty, it basically checks if the string is empty or not. It does not empty it, but it just checks if it is empty or not. And in this case, string 1 is not empty, so it returns a value 0, that it is not true. String 1 is not empty. That's the message that I'm getting from here. However, string 2, which is declared here, is empty. So for this, I'm getting a result true. And this is the exact thing that is expected to be performed by the empty function, right? Then you've got the arrays function, right? So string 4, before we use arrays, is basically C++ programming. And after you erase the 4 characters starting from position 11, so position 11 is basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 including, I remove 1, 2, 3, 4 characters. So if I remove them, my result is C++ program. That is what is left after erasing 4 characters from my string 4, which is C++ programming. From position 11, I get C++ program as my possible result. Then if you move on to the length function of first name, which is basically Elizabeth Jones, right? The length of that particular thing is, so length of Elizabeth, my first name is Elizabeth, right? Yeah, sorry, my first name is Elizabeth. So Elizabeth, the length is 9. It is 9 because 1, 2, 3, 4, 5, 6, 7, 8, 9 in here, right? So the name is the value here is 9 exactly. Okay, and the thing here is you can also see the usage of the escape character here. Escape helps you put these quotes in your results as well. So that's why we are seeing the quotes here. So this is something that I taught you in the first lecture or first few lectures, probably somewhere. Okay. Then if you want to get the length of name, so name here is basically the name, first name plus Jones. So this is Elizabeth Jones, and hence the length of Elizabeth Jones is 15. And in this case, again, you can count the number of characters there, including white space, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 exactly. So that's what you're getting over here. And if you go further, so that's for the name. Then we can talk about length of string 1. And length of string 1 is basically, it is Sunny. And we can again notice that it is Sunny is basically of length 12. Then we go to string 5, which is first name space is space taking space string 4. String 4 is basically C++ program now, right? So we notice that actually string 4 is not C++ program, it is C++ programming because the operator, where is that operator? The arrays function actually returns a new string, but does not store, does not change the current string, right? So in this case, it is Elizabeth. Yeah, so we were talking about the string 1, we talked about it, right? It is Sunny. Then the string 5, which is first name is taking string 4. And in this case, it is Elizabeth is taking C++ programming, or it is of length 36, right? And finally, we can kind of say that, yeah, so sorry. You actually string 4.arrays does change the value. It does not return, and the new string, it changes the value in string 4. That's why we are observing the string 4 as possibly having erased its 4 characters from position 11. But you might remember that when we talk about string 5, this one was formed before we performed the arrays function. The string 4 here was C++ programming, and hence string 5 already contains the value Elizabeth is taking computer C++ programming. And even if you change the string 4, like we did with the arrays function or with the name or etc. other things, they do not change the values in string 5. So in this case, of course, it is Elizabeth is taking C++ programming, and the size of that is basically 36. Also note that backslash null is not included in size, so the length does not cater for the null ending that each string data type has. You already know about that. The other thing now is that we calculate the length of the name, which is first name plus Jones, Elizabeth Jones. And in that case, it's going to be the length is going to be 15 for it. So that is all about the functions that are length that are basically, and this is some way or another example of how a particular namespace is used. I could have used here using namespace size type, right? So then I don't need to declare, you know, I don't need to write string size type and instead directly use, and that would have given me the function or the data type size type as a local data type here, and I won't be confused from which library I'm trying to include the size type, unless I've got a clash, in which case I'll have to mention it. Okay, so let's go to the second example, which is insert and replace functions. And these are some of the functions again which are available within the string, and we can see how they operate when we run them. So I'm just going to run them for you, and we see that how these are operating. So the first string here is cloudy and warm. The second string is hello there. Third string is Henry is taking programming one. String 1 is very, and string 2 is Lisa. So now line 6 is first string is, we just display what first string is, and basically insert at position 10 string 1 within the first string. So this is if you want to insert a string into a particular position within the first string, this is the result that you get. So of course we note that first string is cloudy and warm, and when you insert something here, including spaces, so we notice that very has a space before it. So basically we notice that at position 10, which was this position right after and, we inserted space very, and there is also space after it. So automatically you get double spaces before warm, and basically that string now becomes, after the insertion operation was performed on first string, the first string now reads as cloudy and very double space warm, right? So it is inserted very space is inserted along with spaces right at this point, and hence it becomes cloudy and space very space warm, right? So that is how insert operation works. Let's start with the second string. So at position 11, we basically want in second string at position 11 with another 5, we want to insert an exclamation mark. So what this does when you basically give it 3 characters is that it now expects a position, how many number of characters you want, how many number of times you want to repeat from that position, and possibly the character that you want to repeat. So in this case, since we provided the correct exclamation mark, this is going to be repeated 5 times and inserted at position 11 in second string. So the second string earlier on is hello there, and at position 11, which is the end of this particular character, this string, we actually insert exclamation mark 5 times, and this is the final result for this operation has been performed. So for the third string, we want to replace starting from 0. If you go here, so starting from 0, say 5 times, and you want to basically 5 position, and you want to basically replace it with string 2. So in string 2, we notice that it is Lisa, right? So in this case, we are basically saying Henry is taking program 1. So starting from point 0, right? So this is what we are saying, starting from position 0. For 5 characters, let's remove 5 characters. HENRY is going to be removed by what? the string 2. String 2 here is Lisa. So Lisa, so after replacement, the third string is going to become Henry is going to be removed and by Lisa. So Lisa is taking program 1, and that's the exact output that we're going to get after we use the replace operation. Let's move to the third case. Yeah, so this is all about the three functions here, where we saw how insert works, how the replace works, and what are the effects. So insert has two variations. One is if you want to insert string 1 or a particular string at a particular place, so it will just put it right there. And if you want to put a character multiple times, n times, again you can use the insert function, and this does it for you. And the third example that we saw here is that of replace, which works in a similar manner. So let's go to the next function, which is pig Latin string. And this is a program that reads a string and outputs the pig Latin form of the string. So what is a pig Latin form? Well, it removes actually all the other or everything other than the than the vowels or those or letter y actually. So vowels plus y, it retains them but removes everything else in a particular manner. And this is the way in which you can convert a program into a typical written English word or sentence into its corresponding pig Latin form, right? So every space and everything else is removed, and it converts it into a really peculiar form, which we call the pig Latin form. And in this case, what we notice is, for example, if we use IOStream, vowel, rotate, pig Latin, and other stuff here. I'm not going to go in detail for over this. For now, actually, I'll want to go, but so this is a simple program actually, and in this case, we are using a couple of functions from string, and this is to this is to show the application of how strings are used in a real life scenario with some particular cases. Again, we notice that the cases here are used to display the or statement. So a, e, I, o, u, or a or I, e or I or u, and so on, right? So this is all for the or statement. In all these cases, it should return true, and otherwise it should return false. In this case, we display that size, type, length again is used. Again, you can use namespace here, and I'd love to use the namespace for this particular task. First, we get the length of the string, so we make a new string which is rstr, and in this case we basically get the substring starting from position 1 up till length -1, and then that's substring that we get, and then we add the p string 0 to it, right? So this is kind of saying that it's also reversing the string, right? So this is a reverse string, and this function is going to reverse the string. So it takes the first position, puts it to the end, and adds it with the previous string. And this is the pig Latin string function, the main function that performs everything. And in this case, we simply use the isVowel function, that is a built-in function. Use a size type called counter. So and in this case we say p string is equal to p string plus minus way. So if it is a vowel, we put a minus way in there, and otherwise we rotate it, and we do many other things with this. So this is how we are converting into a very peculiar language which is called pig Latin. And from here what I'm getting is whenever I have a vowel, it basically replaces it with it keeps the string but adds a minus way to it, right? If it is a vowel. And if it is not a vowel, and vowel here is basically something that I've already mentioned is either of a, e, I, o, u, or even y for that matter, right? So for each of these, it is just adding a minus way at the end, even keeping the original string together. So, and it's looking at position 0 at the moment. So if position 0 is a vowel, it just adds a minus way to it. Otherwise, if it is not a vowel, it basically, this is what it does. It adds a minus at the end of it, right? It rotates the original string and returns it in pstr again. So it rotates it completely. So minus becomes first, right? And the p string is actually reversed. And the length is then retrieved. Found vowel is set to false if counter is equal to 1, or counter is so there's a loop that runs for each value in here. And if is vowel p string 0, if at 0th position it's a vowel, we say found vowel is equal to true and break. So until the first vowel is found, we continue to run this, right? Otherwise, If it is not a vowel, then we simply rotate the p string again. So we keep on rotating back and forth, and if it is not a vowel that was found, so if it is not a vowel that was found, then p string is equal to p string dot substring 1 to length. So you get the substring and you add minus way to it, like you do for a vowel. Otherwise, p string is equal to p string plus ay. So if it is a vowel was found, we simply add an ay at the end of it. So this returns a really peculiar form of I don't know, Pig Latin language. I've never heard of this language, but probably it is what we want to do in this particular case. And this is again something that if the rules are clear, you can always form your own languages and form your own code. But since this is not really what you call a very clear problem here, so I'll just leave it to here that this is just a piece of code for you to understand how functions work in particular and how string data type can be used. We use the example of boolean here as well. So how booleans are used and how they can be used can also be seen here, and also the values that are written. So this is a flag, found vowel is a flag and used as a flag over here to perform some particular functions. Anyway, I'll not discuss this more and actually move on to the next example, which is Boolean operation, right? And in Boolean operation, it basically gives us some particular correct strings. For example, hello, hi, air, and bill. So this was also one of the things that we saw, that how different strings can be compared with each other and how Boolean operations work with strings. So in this particular scenario, we noticed that we have got 4 strings initialized by different values, hello, hi, air, and blue. And then we compare them with each other and see that which one is true and which one is false. So if one is true, then that is true, that is written as that. So these are the, if I run all these 4 values, I can see that line 7 is true. So string one is less than string 2, right? So string 1 is less than string 2, hello is less than hi, and that is because I and E, I is capital then I, so I is larger than E, hence the hi is larger than hello. In short, then we compare string 1 with hen, and we notice that this is false. As I said in the lecture, during lecture as well, we saw these one, and we know that basically string 1 hello is greater than hen because hello is not greater than hen because he match, but L and N do not match. So N is greater than L, hence this is false. And that's why we get a false. For the next line, string 3 is less than N. String 3 is basically air. AI is less than AN, hence this is true. So this is true, and we get line 15 is equal to true. Yes, line 15 is equal to true. Then we go to the next line, which says see out. Line 17 is for so this is already done. String 1 is equal to hello. Capital hello and small hello, are they equal? Well, capital H and capital small h are not equal. Actually, capital H is larger than small h, and hence this is false. So we retrieve line 21 is false, and this is exactly what is our solution here as well. Let's talk about string 4 is equal to Billy is greater than equal to Billy. Well, this is true. Actually, string 4 is greater than Billy. So no, sorry. Yeah. String 4 is Bill, and string what we're comparing it with is Billy. So BI double L match, and when there are exact matches, you actually take the larger one as a larger value. Billy is larger than string 4. It is neither equal nor smaller. Hence, this is false, and hence we return string line 25 is equal to false, and this is exactly what we get in, I think, our code as well, right? So when you compare these strings, you need to keep in mind the Boolean operations and how they operate and the rules for Boolean operation. And this is what exactly we see in these examples. So let's move on to the next example, which is string find function. And what does find function do? Well, we can simply just execute it over here and see how the find function exactly operates. The thing to notice here is that what you have is basically there's a sentence outside, it is cloudy and warm, and there's another string that you want to declare which is cloudy. Then you declare the type position as basically of type of the same data type as data of size type within strings. And here we say that line 4, the sentence is this. So that is the line here. Line 4, the sentence is outside is cloudy and warm, right? Okay, the next step is the position of is in sentence. Where can we find is? It is at this position, right? So if I start from here, it is at position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And at position 11, I should be able to find exactly the string. If I start from 0, it starts at position 11, and hence this is the position 11 that I'm getting. So the next step is the position of S in sentence is equal to, so we want to find the position of S in sentence, and the S is actually available at multiple places, 1, 2, so it is available at 2 places. And what we observe, however, is basically the first place where we can find S, right? So the first match of S is going to be at position 3 here, which if I start from here, it's basically 0, 0, 1, 2, 3, right? So that's the position that is returned. So the next step is the position of string. So now we can also find a whole string inside it, and that's basically we are trying to find where cloudy is located, and cloudy is located at position 14. We already know that. So this is where if you want to try a position this, you should do a position of a string here. You simply use the string inside a sentence.find string and convert that to a integer. Then you've got the position of the this in string. So in this case, we want to basically locate the position of the in string. Where is the located? And the we can clearly see is not located anywhere. Hence, the position of the is returned. If you try to convert it into integer, this is a very large value. This is basically junk value actually, and the function did not return actually any good value here. So because that is not located in the function, so it basically returns, it should ideally return the max value, the minus infinity value, and this is, I think, what it is doing. It's returning the max value, or it should ideally have returned a negative value, but since you try to convert it into an unsigned integer, that's why you're probably getting this particular error. And maybe maybe a signed integer might have been a better choice to convert it into. So finally, the first occurrence of I in, okay, so the first occurrence of I in the sentence after position 6, right? So you want to find I after position 6, and that position is 0, 1, 2, 3, 4, 5, 6. The first occurrence of I after position 6 is basically 8, and that is exactly the thing that we find in the sentence as well. So this shows different variations of how the function find can be very useful in finding a particular string or a particular character that is present or not present, or to search for it after a particular location as well. So this is how you're going to use the function find and find for strings. So let's talk about some string operations here. So these are a list of string operations that can be ran, and I'm not going to run it for now because I just have to kind of complete this lecture pretty quickly. So we see that there are some strings that are declared, and well, after strings are declared, they are displayed, and then we just kind of perform different functions on them. So for example, string 1, we at position 6 we want to replace it with t, and after this replacement we get a particular value. So in this case, you want to enter a string without blanks, right? And in this case, you can enter a string with blanks, and you see the difference, and so on. So these are the different things that we can see here. I'll just move on to the next example so that I can kind of wrap up the lecture quickly. And this one is an example on a substring function, how a substring function operates. And we can just simply run this code for now and see the operation of substring function. In this case, substring function basically gets a part of the string and returns it basically. So it's not going to replace the current function, but it just returns it. It does not replace them. And in this case, it's like a new substring that gets returned or new string that gets returned. And then you can store it and use it otherwise. If you don't store it, it's lost. Remember that. So that brings an end to my examples for chapter 7. I hope you learned something in this particular chapter about strings, about enum, and you'll be able to define your own data types and use them as much as possible. Especially the enum data type is very useful for exams and for project. We'll talk about it later in the next lectures. Thank you very much, and I hope you've learned something in this lecture. Take care. Allah Hafiz.